Hi, everyone, and welcome to AstroNights Live, presented by the Krista McAuliffe Center for Integrated Science at Framingham State University. Once again, we have a fascinating presentation planned for you, and we're very excited that you chose to spend a little of your time with us tonight. Our presentation will be about 20 minutes in length, after which we'll be able to address a few of your questions. Those of you participating on Zoom can post a question via the Q&A window. Be sure to hold your question until the end because it might just get answered during the presentation itself. If you're joining us via YouTube Live, you should know that Q&A is not available, so just sit back and enjoy. Whether you're joining us on Zoom or YouTube, we recommend taking a moment to locate the full screen mode in your app for the best AstroNights Live viewing experience. And all of our websites and resources we'll be discussing during our program are available on our website. So don't worry about rushing to write them down. Just relax and enjoy the program. The links will be waiting for you whenever you're ready. You'll be invited to complete an online survey at the close of the program, and we hope that you take a moment to share your thoughts with us. Your feedback helps us in planning future AstroNight Live events. And now I'd like to introduce you to our presenter, Mary McDonald. Mary is the planetarium manager at the FSU Planetarium, and I know she's anxious to get started. Mary?
Thank you very much, John, for that lovely introduction. And welcome everyone to AstroNights Live. As we often do at AstroNights, we are going to get started with a look at tonight's sky. So we're going to take a look at what your sky will look like at about 7:30 tonight. So a little before we wrap up here. Let's take a look at what is visible. So as you can see, and you've probably been noticing for the past couple of weeks, the sun is very much still out at this time of evening. So it takes quite a while for the sky to get nice and dark. We're gonna watch the sunset and take a look at what is visible after dark tonight. Let me put up the time so that we can all pay attention to what time it is, because I do want to remind you that one of our main goals with AstroNights Live is to give you some pointers on what will be visible in your actual night sky so that you can go outside maybe right after the show is over or maybe tomorrow night and take a look for yourself. So important things to pay attention to are the time and the direction that we are looking in. I'm going to go ahead and turn off my own video so that we can all focus on the night sky. All right, so as you can see, we have the sun setting over in the west. Let's let that sun set. And the bright light that you notice just above the sun is the planet Venus, pretty well visible tonight. Our introducer tonight, John, was saying that he had a great view of Venus recently. And Mercury is actually visible as well. Not quite as bright, but as you can see, Mercury will be setting a little bit later, so it may be easier to catch it in the night sky because it'll get nice and dark, and that might help you to see Mercury. Also, it's up a little higher, so you may be able to see it above your buildings and trees that are around you. But we're not actually going to be talking about the planets tonight. We're going to be talking about some other topics. However, good things to look out for in the night sky, always the planets. We also have a lovely view of the moon just after first quarter. But we're going to be talking tonight about other things. We're going to be talking about stars. Oftentimes when I'm deciding on the topic for each month's presentation, I want to look at what is easily visible in the night sky that month. And many times, some of the first things that amateur stargazers look out for are the constellations. So we are actually going to talk about a particular constellation tonight. And then we're going to go on and talk about kind of what I consider important about the constellations. It's not the stars themselves or the patterns they make, but constellations are full of interesting things to look at. So identifying the pattern of the stars is really just the first step, and then you really get into the interesting stuff. So we're going to talk about a particular constellation and some of the objects that are found in that constellation. And maybe those terms will make a little bit more sense to you later. So the constellation we'll be focusing on tonight is Virgo, and it is actually pretty much right in front of us in our view in the sky right now, but it is not a very easy one to find. It doesn't have a very memorable, easy to find pattern. So it's not one that I'm going to recommend you go out and just try to find right away. So we're going to use some tricks to help us find this constellation, and we're going to start with one that is actually quite easy to find. There's nothing easier to find in the sky for most of us than the Big Dipper. So that's what we're going to start looking for tonight. And you may know that to locate the Big Dipper in the sky, you usually want to look towards the north. So we're going to turn towards north. And think about the fact that if you were outside, looking at the real sky, that would just mean turning your body. But here at AstroNights, we kind of do the opposite. You stay in your seat, I turn the sky for you. All right, so we're looking north. We still don't see the Big Dipper though. So the reason for that is because it happens to be pretty high up in the sky right now, this particular time of night, this time of month. So I want you to imagine standing outside and tilting your head all the way back to look almost straight up. So again, because we're here at AstroNights in kind of a virtual sky, we're going to do the opposite, and I'm going to tilt the sky up for you. Okay, wow. So we're looking so far up in the sky that we can't even really see the ground. And in fact, we happen to be looking pretty close to a spot in the sky known as the zenith. So the zenith is a, hypothetical spot that's directly over your head. And right now, at 9:18 tonight, the Big Dipper is pretty close to the zenith. So hopefully some of you have already picked out the 7 stars of the Big Dipper. Here it is. Now, you may know that the Big Dipper is famous for the trick we can use to help us find the North Star. So to do that, you use the scoop of the Big Dipper and the scoop of the Dipper, the last 2 stars here, they point towards the North Star Polaris. But that's actually not what we're going to be doing tonight. We're going to be using the Big Dipper to help us find a different star. And for this, we're going to be using the handle of the Dipper. So the handle is kind of pointing in the other direction. So I hate to make everyone dizzy, but in order for us to see this a little bit better, I want us to turn towards south again. So let's turn towards south, but remember that in this direction, we're still going to want to look up in the sky. So this is something that would be a lot easier in the real sky. You would just turn your body around and look up again. So right now we're facing south, just like we were before. And now we're going to tilt our heads upwards in the virtual world. And now we're looking up at the zenith. Okay, so we're now looking at the handle of the Big Dipper. And you can see the handle kind of appears like a curved line, or in mathematics, we might call it an arc, A-R-C. So the trick is you follow the arc to Arcturus. arc to Arcturus. Oh, I should have mentioned, this is the star we're looking for. It's a star called Arcturus. And actually, this time last year, I was just watching the video myself, May 15th, 2020. We did a AstroNights episode called The Spring Star, which was all about the star Arcturus. So it's known as the spring star because it is the brightest star in the springtime sky. So for those of you who maybe live really close to the city, maybe you've got really hazy skies tonight, you might not be able to see all the things we point out. But if it's even a little bit clear, you should be able to find the Big Dipper and this star Arcturus, because it's the brightest star in the sky right now. And if that's all you do, if that's the only thing you do as a result of watching AstroNights tonight, I will be very happy about that. But that episode, we used the Big Dipper to find Arcturus, talked a little bit about this star, talked about a couple of other constellations. Today, we're actually going to go farther. We're going to go from Arcturus to something else, because that's not our topic tonight. Arcturus is a part of a constellation called Boötes. And this is one I like to point out in summer, because many people think that Boötes looks like an ice cream cone. So these stars here make the little pointy cone, and then these stars make up the scoop of ice cream. So there it is, the ice cream cone of Boötes, which makes just about as much sense as whatever the actual constellation is supposed to represent. But now I want you to not think about Boötes. I don't want you to think about an ice cream cone. Now we're going to think of this as a spike. So instead of an ice cream cone, it's a pointy spike. And the next trick after arc to Arcturus is you follow the spike to Spica. So follow the point to the brightest star over here. And this is Spica. What is Spica? That's another star. So this is actually the star we're looking for tonight. And it's not a particularly special star, but it is the brightest star in the constellation Virgo, which is the constellation we were trying to find. So I told you that this pattern of stars is not particularly easy to find in the sky, at least for me, that's my experience. But if you use that trick, once you have found Spica, you know you're looking at Virgo. Now, it might surprise you that Virgo is a challenging constellation to find, because it is actually the second largest constellation in the sky. And I want to talk a little bit about what that means. What does it mean for a constellation to be large? So first of all, remember that these patterns of stars that humans, picked out thousands of years ago, and people continue to do it today and make up their own patterns, that's not really any kind of actual physical system. These stars might not be anywhere near each other in space. They just appear that way from our perspective on Earth. So the patterns don't really mean that much, but there's more to the constellation than just the pattern. Each of these patterns is also used to designate a certain region in the sky. So this is the region of Virgo. And now we're getting to the point of understanding what is a little bit useful about constellations. You can think of them as sort of landmarks in the sky, or as a way to map the sky. So if you're looking for something interesting in the sky, you're searching for something, or you found something and you want to maybe explain where it is, you might say that it's in a certain constellation. A great example of this is if you were looking for a comet. For example, last summer, there was a very highly visible comet. And if you wanted to figure out where to look in the sky, you might want to know what constellation it was in. And that's an interesting example, because what we all know about comets is that they move. So over the course of a few nights, the comet may not be in the same constellation the next night. And that's also true of the moon over here. So we started tonight looking at the moon, and the moon is actually in Virgo right now. And like comets, the moon moves. It orbits the Earth. So take a quick look at the time and date up here. We're going to jump forward by 24 hours. So we're going to look at tomorrow night's sky. And you see the moon's in a different location, but still in Virgo. Then the next night, still in Virgo. But by May 24th, the moon will not be in Virgo anymore. So this is a good example of something that moves rather rapidly through the constellations. But because Virgo, this area, takes up such a large region of the sky, the moon ends up spending a couple nights in this part of the sky. So our next topic of discussion is we're going to talk about some other things that are in Virgo. And these are things that are going to remain in Virgo for a long time. It's not that they don't move, we'll talk more about that later, but that their movement is not as easy for us to notice as something like the moon or a comet. So these are objects that for the time being, we can say they are in Virgo. And I'm going to go ahead and label some of these objects. And maybe you might start to sense a little pattern. Okay, we got quite a few things here. So you see a lot of these objects kind of all in the same area in Virgo. I will tell you that everything I have just labeled is a galaxy. And your first thought might be, why are there so many galaxies clustered together here? And second question, we'll get to that. Second question is, what's with all the M's? So I will tell you that the M stands for Messier, which is a reference to Charles Messier, an late 1700s astronomer who was the first person to observe and record the locations of these objects. So Messier, like a lot of people in the 1700s, was very interested in something that I just mentioned a moment ago, comets. A lot of people at that time were obsessed with looking for comets. People have always been interested in comets. They seem to be somewhat mysterious. They appear and move across the sky and then eventually disappear. So humans have often attributed a lot of significance to comets that they don't necessarily deserve. But for scientists, Messier and other scientists at the time, they were really interested in comets because, again, comets move. They orbit the sun, and they're a great way to study and learn about orbital mechanics, which was a concept that was really just starting to come together at that time. It doesn't hurt also that if you were to find a comet, you would certainly get a lot of fame and maybe even get the comet named after you. So there was a strong motivation to search for comets. Now, if any of you did look at the comet last summer, you would have seen that it essentially looks like a blurry blob in the sky. And so Messier was looking at this region of the sky, and we're going to start to zoom in on that. He was looking at this region of the sky and seeing a lot of fuzzy blobs. But because he understood about how comets are supposed to move, how he expected them to move, he recognized that these objects were not moving in that way and therefore were not comets. So he decided, let's zoom in, not out. He decided to record the locations of these objects and make a catalog of them so that the next person who was looking for comets would be able to check this catalog and know right away that the fuzzy thing they saw was not a comet. And this list that he started is now known as the Messier catalog, and it is a catalog of some of the most beautiful objects in the universe. Things like star-forming nebulas, supernova remnants, massive star clusters, and galaxies. Of course, he didn't know what these things were at the time. He only saw them as fuzzy blobs and was pretty sure they weren't comets. So now we have this treasure trove of beautiful objects called the Messier catalog that have been observed by the greatest telescopes of our time, including the Hubble Space Telescope. And I really recommend you check out the event page, which I'll share again later. It has some great resources on finding beautiful images of Messier objects. But anyway, not every single object here is one that was observed by Messier, but a lot of them are. But why are there so many together here? Well, as our understanding developed and we got to know really what a galaxy is, we began to see that galaxies appear to cluster together. So there are places in the sky where there are a lot of galaxies and places where there are hardly any at all. And we now know these as, of course, galaxy clusters. So the Virgo cluster is a relatively nearby cluster to us. It's only about 54 million light years away to the sort of center of the cluster. And it contains over 1,300 galaxies, possibly as many as 2,000. As we zoom in a little more, you may notice that M49 here is the brightest, but the center of the cluster is M87. And we'll talk a little bit more about that one and what makes it the center. But let's first focus on another one, M60 over here. And I think just taking a look at this one is really going to help us understand what a treasure trove we have found of galaxies. Because when you get a closer look at M60, and I do want to point out, I hope it's clear that these are all objects that are not visible to the naked eye. Even with many backyard type telescopes, you would be unlikely to be able to observe many of these. But if you have a decent enough telescope and very clear skies, you may be able to detect some of these fuzzy blobs as Messier did. But now with our more powerful telescopes, we're able to resolve these amazing objects and see the diversity of different types of galaxies in this cluster. So with this pair right here, we thought it was just one, but we actually have two here. We see the two major types of galaxies. M60 right here is a giant elliptical galaxy, and the one next door, which is NGC 4647, is a spiral galaxy. These are the two major types. They're very, very different. Spiral galaxies, that's the type of galaxy that we live in, the Milky Way. And I'm going to turn on my camera briefly because I have some fun hand motions to do regarding the shape of the different types of galaxies. But of course, first I had to switch my virtual background. Okay, so spiral galaxies, like the Milky Way, are flat disks, essentially, not totally flat. They're flat disks, and so sometimes when we see a galaxy, we see it from the edge. So we might really see that flat disk-like shape, but sometimes we see them face on like this. And that's what we're seeing with this galaxy here. We're definitely seeing a face-on view. So we see the full spiral arm from above, you might say. On the other hand, elliptical galaxies like this one are spherical. So we expect that they would look essentially the same no matter what direction you were looking at it from. Of course, with the spiral galaxy, in addition to the disc-like shape, you see the spiral arms. So you see these patterns of where the stars are, are densely located. No such pattern with an elliptical galaxy. And finally, the other difference you may notice is the color. So a spiral galaxy being very blue tells us that there are a lot of blue stars, and blue stars are the ones that are big, they are bright, and they don't live for a very long time. So if you're seeing a lot of these blue stars, you know that they were born relatively recently in their lifetimes. They're, relatively young stars, we might say. And they haven't died yet, and that means that the galaxy is continuing to create new stars. So if you're seeing these young stars that don't live for very long, the galaxy must be still forming stars to replenish the supply of blue stars. But on the other hand, the elliptical has mostly gold, yellowish color. All the stars that are making up the majority of this galaxy are smaller, redder stars. So there's smaller individual stars, but more of them. So it's a very massive galaxy. Any blue stars that may have existed in this galaxy have long since ended their life. So there's no blue stars left, and the galaxy is not forming many more stars. So there's almost no star formation going on in this galaxy. You're seeing a lot of old stars. So just, I think, a really beautiful example of the two main types of galaxies. The interesting thing about M60 is that these little bright dots that you see on the edge, those are also galaxies. So those tiny little dots like these here are smaller galaxies that orbit the main galaxy. Really interesting. And one of them, I posted an article on the event page about one of them. It is a dwarf galaxy, a special type known as an ultra compact dwarf galaxy, meaning a lot of mass packed into a small area. And it may be the densest galaxy ever observed. So if you'd like to read about that, it's on the event page. Anyway, now we're going to go back and take a look at M87. And I really don't want to make people dizzy. I'm trying to be careful here. All right, M87, let's go back to this one. Now, this name may be slightly familiar to you because this particular galaxy was in the news quite a bit a few years ago. M87 is the center of the Virgo cluster of galaxies, which makes sense because it is the largest of the galaxies. So when we say the center, it doesn't mean we just look at where they all are in the sky and look at which one's in the middle. We mean we look at how the galaxies move with relation to one another, because they do move. They're so far away that their movement is not easy to observe. So back in Messier's day, he would not have been able to observe it. But now that we have more advanced telescopes, we can detect their motion. And the motion of the galaxies indicates that the gravitational center of the cluster is M87, which is an incredibly massive galaxy. It's known as a supergiant elliptical galaxy. It has several trillion stars. It may be one of the most massive galaxies in the known universe. And the reason why you may have heard of M87, and maybe it's not coming to your mind right now, is because a few years ago, M87 was the center, if you mind the pun, of a very important scientific result. So like most galaxies, M87 hosts a supermassive black hole at its center. And this particular black hole was the first one to ever be imaged by the Event Horizon Telescope in 2019. So I want to just point something out that's very misleading in what I just showed you. So M87, a supergiant elliptical galaxy, is huge. It's a really, really, really large thing. Supermassive black holes, despite their name, are tiny. So the supermassive black hole is located at the very center of the galaxy. And in fact, that is still extremely misleading. I could not possibly draw a dot small enough to indicate how small the black hole is. That's one of the things that makes black holes what they are. They are incredibly tiny, technically infinitely small, with a huge amount of mass. So they're super massive. There's a lot of material, but packed into a very small area. So I just want to make sure that I'm not misleading anyone by putting this image right on top, because they are not the same size at all. The supermassive black hole is very small and at the center. So let's talk about this image, which I'm sure you all saw because it was on every single newspaper. It's of course not actually an image of a black hole. That's not possible. Black holes do not allow any light to escape, so you cannot capture an image of something if there is no light to capture. What you do capture here, though, is the shadow of the black hole. So this region in the center is the shadow of the area known as the event horizon, the point beyond which no light can escape. And you can't see anything that's beyond inside the event horizon, but you see a lot of light around it. In fact, the region around black holes happens to be some of the brightest, most luminous things in the universe, because around this black hole with its immense gravity, you have stars and gas and stars that have been torn apart, and they are being pulled in by the black hole's gravity. And I don't want you to think about things just falling into this black hole. What happens is that they fall into orbit around the black hole. And many of these objects never will actually enter it. They will just orbit around it forever in very stable orbits. But the gravitational forces here are so strong that this material gets heated up to incredibly high temperatures, which creates this often extremely bright luminous radiation. So that's M87. And I did put some resources related to that black hole and the discovery, and some recent news about the black hole that came out this year. It's all again on the event page. So last but not least, I just want to zoom out a little bit and think about galaxy clusters in general. So the Virgo cluster, first of all, some of you may be wondering, are we in the Virgo cluster? Are we part of this cluster? No, we are not. Our galaxy, the Milky Way, is a part of a smaller cluster called the local group. And then the local group and the Virgo cluster together are part of a bigger cluster called the Virgo supercluster. So the Virgo supercluster is a cluster of clusters, and Virgo here, we'll say this is, let's call this the Virgo cluster. It's actually much bigger. It's the biggest cluster in the supercluster. So again, when scientists wanted to understand how all this worked, they started looking at how did the galaxies move? And then even how do the clusters move? So within the supercluster, we expect that all of the smaller clusters will move towards Virgo. So all the smaller clusters should be moving towards the biggest cluster. But that is not what they observed. They observed that all of the galaxies in Virgo, in the local group, most of them anyway, and on all the other smaller clusters, appeared to be moving in a different direction towards what they weren't totally sure, but they called the region that they all were moving towards the Great Attractor, which I think is a very cool name. Now, our understanding is that the Virgo supercluster, which again includes the Virgo cluster, it includes the local group, which is us, it includes other clusters, all of that supercluster is actually just one small part of an even bigger supercluster, which is now being called Laniakea. So I do have some resources about that on our event page if you'd like to learn more about that. But one thing that I really hope you take away from this is that just looking at the sky, recording the locations of things, looking at what's next to what, and trying to put together a picture of the laws of nature from that is not going to work. That's a very old-fashioned way of doing astronomy. We now really need to look at how objects move with one another, because that tells us how they are interacting with relation to gravity. And these clusters, like the Virgo cluster, are some of the most massive objects in the universe. So these are where the gravitational forces are really, really significant. Very massive objects, a lot of gravity. These give us a great opportunity to study gravity, which is really what it's all about. That's where all the relationships come about and how we really start to understand the laws of nature. All right, so that's going to do it for my input tonight. I would now like to turn it over to questions from the audience. And I'm going to let you know, I had a lot of different topics tonight. So a lot of topics, I may not be able to answer everything. And I may not be able to answer them super fast. But all of you in the audience, you should be able to locate the Q&A feature. I would like you to put your questions in the Q&A, not the chat, but I will turn the chat back on in case anyone needs it to share anything. But let's put your questions in the Q&A. I'm going to give everyone a second to enter them, and then I will look them over before I get started. But let's take a look. Okay, I'm going to start with an easy question. I'm going to give myself a softball. So I have a question that is, why is it called, why is it called the Virgo constellation? Okay, sorry, I misread that. I thought the question was, why is it called the Virgo cluster? That is an easy question. It's because, as we discussed, the cluster is in the region of the sky of Virgo. So that's why that's called the Virgo cluster. Why is the constellation called Virgo? Virgo is Latin for, and I have some nice notes on this. It's Latin for the maiden. So unlike some of the other constellations like Orion, it doesn't represent a specific character. It just kind of represents a maiden, a young girl. But throughout history, different cultures have claimed it to represent various different goddesses or even actual people. So Virgo has been associated with the Roman goddess, and the goddess Astraea, who is a goddess of justice. And Virgo was once associated with England's Queen Elizabeth I. So yes, it's a constellation that has a lot of cultural significance. Okay. Great questions, many that are great. Okay, I have a question up here. I might, I'll answer the whole thing. Okay, how would you find a new comet if they move so fast and we don't know when they will come? Great question, because I mentioned that the constellations might be a way that you might look for something, and like when you're looking for something in the sky, or someone like Messier was looking for comets. It's kind of a misconception that comets move fast. When we say they move fast, we mean like compared to galaxies or compared to even the stars. They don't actually whip across the sky like you might picture when you're picturing a cartoon. They move pretty slowly over the course of a couple of days. So I'm going to just remind you of the moon. So the moon, we say the moon moves fast. If we look at the moon tomorrow night, it's in a different location, the moon the next night in a different location, and so on. So that's about as fast as a comet moves, in the sense that each night it appears in a different location. So in some cases, comets might move slightly faster than the moon, but not much more than that. Now, the thing is that the moon isn't actually that fast. The orbit of the moon around the Earth isn't an especially fast orbit. Comets doesn't necessarily mean they're moving fast. It also has to do with how close they are to us. If the object is closer to us, we notice the movement more. It appears faster. I think a good analogy is if you're near an airplane, it appears to be moving really fast. But if you see an airplane really high up in the sky, it doesn't appear to be moving fast at all. But of course, we know they are. So yeah, so comets aren't necessarily moving very fast, but you're right that we don't necessarily know when they will come. if it's a new comet that we didn't know about. There are comets like Halley's Comet that we know their orbital period because other people observed it. We were able to figure out their orbit, and we know when they will return to a place in their orbit when we can see them. But for new comets that are observed for the first time, I have to say, I'm not exactly sure how people know to observe them. They probably just get lucky to some extent. I want to turn my video back on for answering questions. In the same question, it was, how big is the Milky Way compared to other galaxies in the Virgo cluster? Well, one thing I want you to know about the Virgo cluster, and you can find some beautiful images of it on the event page, is that there are thousands, between 1,000 and 2,000 galaxies in this cluster. Some of them are bigger than the Milky Way, some of them are smaller. But a lot of those, most of the giant elliptical galaxies that we looked at are significantly bigger than the Milky Way. So giant elliptical galaxies are generally much bigger than spiral galaxies like the Milky Way. Okay. Lots of good questions here. Is an elliptical galaxy just an older type of galaxy? Did it ever have blue stars? That's a great question. And it's a really, really excellent deduction from what we looked at to come up with that idea. In a sense, yes. And there were definitely thoughts when we were first starting to see the different types of galaxies, there were thoughts that there was some sort of evolution, that one type of galaxy evolved into another type. It's not quite as simple as that, but yes, elliptical galaxies are older. Yes, they used to have blue stars, but those blue stars ended their lives. So as you may know, large, massive blue stars end their lives in supernova explosions. So they just go away. And the material that made up those stars goes out into the interstellar regions between other stars and leads to the formation of new ones. But eventually, there's not enough material left to make new stars. So we do now think that elliptical galaxies, many of them are former spirals, but it's a little bit more complicated. We think that collisions between galaxies play a big part into it. So it's not just one galaxy turning into a different type of galaxy. We think that collisions really do affect this evolution of galaxies. And that can help explain why not only the star populations, but the overall shape of the galaxies are different. I hope that answered that one. Okay. I have a nice question. Does every galaxy have a black hole at its center? That's one of those tough questions that it might not be answerable to be able to find out truly if every galaxy has a black hole at its center. We believe that the majority of large galaxies do have black holes at their centers. We're not necessarily able to observe or detect every one of them, because some of the regions around the black holes are more active than others. For example, we do know that our galaxy has a black hole at its center. Because we're able to observe, because we're in it, so we can observe it a little bit better, we can look at the gravitational interactions of stars near the center, and we've been able to figure out that there is a black hole there. But if we were to see our galaxy from afar, we might not be able to detect it, because our supermassive black hole is known as a quiescent black hole. So it's not luminous itself. It's not especially luminous. So there are definitely black holes out there that we might not be able to detect. One result I saw recently was a study of really small irregular galaxies, which we might have thought didn't have black holes at their center because they're really small and they're funny shaped. But studies do indicate that many of these do have black holes at their center. So there is a lot of evidence to point to, yes, they all do. Okay. Let me check out some more questions. Okay. All right. So I have a question here that I'm going to answer just because I'm going to be a little bit cheeky. I think the question is, are constellations the best part of space? And at the McAuliffe Center and FSU Planetarium, we have a very strong opinion on this, and our answer is no. We do not consider constellations the best part of space or the most interesting thing to talk about. So I hope you got from today's from today's conversation about constellations, that there is some use for constellations, especially as like, you know, a beginner sky watcher, stargazer, just being able to identify some things in the sky, being able to see, oh, this is a pattern that I see every night. I saw it last night, now I see it tonight. Like, that's really good practice. And then, you know, to be able to say, oh, that pattern I only see during winter, that pattern I only see during summer, it's very helpful. And then today we talked about the idea that constellations can be used as sort of a map of the sky, but only to help us find more interesting things like galaxies or comets. So no, they are not the best part of space, and in my opinion, not the best part of space science discussions. So that's my answer to that one. Okay. All right. So let's see. About what time tonight will we be able to see things in space? So I assume you mean what time tonight will we be able to see the things we mentioned today? So if some of you may not have been able to see this too well. It's in the upper corner, but I do have the time and date up. So this is tonight at 9 p.m. So if anyone looks out their window right now, if you're, you know, in the East Coast region, like East Coast of the United States, it's not dark yet. So you won't be able to see these things right now. So around 9:18 tonight. But I do want to point out that Spica is a little bit low on the horizon. So it's pretty close to the horizon. So when I went out around this time last night, I still had like some really kind of tall trees in that region. So do keep that in mind, that things that are lower on the horizon might be a little bit trickier to find. But things that are high up overhead, like the Big Dipper, which we looked at earlier. Wow, it's really far overhead. Yeah, are always very easy to find. Okay. So if there are any more questions, we'll take maybe about one more minute with questions. These have been some very good ones. I think we'll stop there then. I do want to once again encourage everyone to check out our website. I'm going to actually go ahead and just share everything I shared earlier, or everything that I shared with my coworkers. All of the links you can check out for our main page, tonight's event page, which has a lot of great resources. Oh, okay. Very good. Okay. So please check that stuff out. A lot of the answers to questions that might not have come up tonight, you might find on some of our resources there. But I do hope that you will all join us at AstroNights next month and at any of the future McAuliffe Center events that you may find out about if you join our mailing list. So thank you once again, everyone, for joining AstroNights, and we'll see you next month.